Hello my dear friends, welcome to my YouTube channel ANIRUDH'S Chemistry World. Today we are going to start a very new chapter, that is Class 12th Chemistry, Chapter 4, that is Chemical Kinetics and Nuclear Chemistry. We are going to deal with Chemical Kinetics and Nuclear Chemistry. Actually this is a chapter which is a combination of two chapters. That is, first one is Chemical Kinetics, which is related to the rate of a reaction, and second one is Nuclear Chemistry, which you will be always seeing in the other chapter, that is atomic physics. There also you will be seeing the nuclear chemistry, name the chapter nuclei. Okay, but some part of this is deleted, and you should only know basics of this nuclear chemistry, but our main focus is on chemical kinetics itself. Okay, let us start this video. We'll see rate of a reaction. Rate of a reaction. What does the rate of a reaction mean? Rate is itself means the speed at which the reaction is done. Rate means the speed. Rate of reaction means at which speed the reaction is being processed. And in how much time the reactants are converting into products. That's the only main concept behind this rate of reaction. In the whole chapter, we will be only seeing the rate of reaction and the topics related to it. That's it. But it's a part of physical chemistry. Okay, we'll just define the rate of reaction. It is the speed. It is the speed. It's a rough. I'll again write somewhere with a proper explanation. Let us first define the rate of reaction. It is the speed with which the reaction is processed. Instead of process, we can use a proper word. It is the speed with which the reaction is performed. That is a better word. Reaction is performed. There are in this world, in this real world, we have multiple reactions. Suppose the reactions involving carbon you will be seeing later in nuclear chemistry, where it takes years to complete the reaction, and some reactions you need to just combine them. The time with which you combine is less. Okay, even if they are closer like this, they are combined, means they are very explosive. Like, okay, suppose there is sodium. The sodium is there. You kept one sodium metal. Okay, it even reacts with the oxygen present in the atmosphere readily. It readily reacts with the oxygen. Means the amount of reactants it has is very high. If you take carbon decaying, it's a process. It takes years and years to complete the reaction. Means this is the difference you need to observe in this rate of reaction. This rate of reaction can be either very fast or very slow, depending on the type of reaction. You will be having the perfect name for the rate of reaction, which will take more time, is carbon dating. Carbon dating, where the decomposition of carbon occurs of an organism or any kind of organic matter, where it will take some around 100 years or 200 years or sometimes even 1000 years. This is the thing which happens. And if you take in the sodium reactions, since sodium, these alkali metals are highly reactive, they'll readily react with any other elements. Okay, this is the just basics and introduction. You should first understand, visualize, and then apply the concepts. This is the motto of this channel. Okay, let's see. The rate of reaction is the speed with which the reaction is performed. Okay, this is the definition. The rate of a reaction is denoted with R. Okay, right, in normal cursive writing, it's individual writing. So R, this is the symbol which you will be seeing in the rate of reaction. Okay, rate of reaction is denoted with R, letter small r. No need to worry about this. You will be seeing in the formulas and other concepts linked to this. First, take this basic definition. and I'll give what is the concept behind this chemical kinetics. Just notice now. I'll give you some 5 seconds. Better you take a screenshot when I give time, so that you can easily revise the concepts after completing this video. Okay. Now, okay, let us give this heading like this. At this part, I am going to explain what is chemical kinetics. Chemical kinetics is a part of, or part instead of part, we can use a better word. Chemical kinetics is a branch of physical chemistry. Related with the rate. Chemical kinetics is a branch of physical chemistry related with the rate, mechanism of a reaction. This is the main motto of this chapter. This is the main goal of this chapter. This is the main goal of chapter, where this chemical kinetics is a branch of physical chemistry. In chemistry, you will be having 3 parts, right? Organic chemistry, inorganic chemistry, and physical chemistry. This physical chemistry mainly deals with the numericals. If you go with the competitive exams like JEE, NEET, where 95% of the questions will be on this chapter will be based on numericals. So one thing is to be clear, that you need not memorize the definitions, just understand the definitions, and don't waste more time on the understanding definitions. You should understand the definitions, but don't try to remember that, okay? Don't try to remember in a complex way, as I told. You can even remember in your own way by understanding this, okay? By understanding this, you need to apply the concepts by on the questions which I provide. In this video, we will be seeing the theory and the formulas related to the chapter. We'll be, by using that formulas and tricks, you can solve the questions very easily. So here my main target is to provide the basic information of the chapter, give you the formulas, and apply those concepts in a very easy way. Right? So chemical kinetics is a branch of physical chemistry related with rate and mechanism of a reaction. I think you heard about the mechanism. Mechanism means how the reaction, internally the reaction will work. That is the mechanism means. You might have heard about this mechanism in the organic chemistry, where a reaction is you will be seeing the reaction. You will be seeing the mechanism of the different types of reactions like chlorination, bromination, and I think you have saw this reaction in your 11th grade. That is CH4 plus X2 gives CH3 plus CH3X plus CH3X. You'll be seeing this type of reaction. This is a major product. Okay, this CH4 plus X2 gives CH3X. This is a basic reaction. I am just telling this not to confuse, just to make you understand in a better way. Since you have already studied in 11th grade. In 11th grade, you had one chapter, General Organic Chemistry, where you have heard about this mechanism. So I am just revising this concept for you. Mechanism is nothing but, see, this reaction is there, CH4 plus X2 gives CH3X. What is the mechanism behind this is, means how the internal processing of this reaction is that this X, that is halogen, X means halogen, this halogen, how it breaks, here breaks and it forms a free radical like this, and it reacts with CH4 such that this will replace one hydrogen here, and the internal reaction will occur like this, right? Okay, the CH4 plus X2 gives CH3X. Means this free radical mechanism, this reaction follows free radical mechanism. This is the mechanism with which the reaction processes. This is known as free radical mechanism. You might have also heard about this Markovnikov's rule, Markovnikov's mechanism, anti-Markovnikov's mechanism, and you have so many mechanisms in your organic chemistry. You will be seeing and encountering that in your 12th grade also. Okay, don't worry about that. First of all, we'll discuss the basics of this chapter, and we'll enter into the real concepts, core concepts in this. You just note this down, and I'll be discussing the formula related to rate of reaction. Okay. I think there's no need to note this down, but for your understanding, you can note in your short notes. Yeah. Now we'll see another definition for rate of reaction. In our chemistry, chemical kinetics, in the point of view of the chemical kinetics, we'll be seeing the rate of reaction. What we define how the speed at which the reaction is performed. That is basic definitions for your understanding. But according to the chemistry, you need to define in a proper way, in an organized way. You cannot write the definition which I provided earlier in your exams, board exams, because that's very general way. Now I am telling you a proper way with which you can write the definition in your exams. Okay. The first thing is this is proper definition and very, very important. You need to remember this. Okay. The rate of reaction is the decrease in the reactants, the decrease in the we'll be defining the rate of reaction in two ways. We'll be defining the rate of reaction in two ways. That is the decrease in concentration, the decrease in the concentration of reactants. The decrease in the concentration of reactants or increase in formation of products, increase in the formation of products is called rate of a reaction. I hope you understand this. Okay, it's a very easy definition. Rate of a reaction is nothing but the decrease in the concentration of reactants or increase in the formation of products is called as rate of reaction. I will be explaining you, don't worry, with a better example. Okay, decrease in rate of a reaction is defined as the decrease in the concentration of products. The decrease in the reaction of reactants or increase in the formation of products in a unit time. Is called as the rate of reaction. Now we got the proper definition. See, in the starting I told you about the speed. The rate is nothing but the speed of reaction. What is speed? In physics you have heard what is speed. Okay, the distance traveled by the time taken. That speed is equals to distance by speed. So distance by time. The speed is equals to distance by time. Now similarly, the rate is also equals to similar to that of distance by time. That's why we define in a proper way with unit of time. Okay. Now the rate of reaction is nothing but the decrease in the concentration of reactants or increase in the concentration of products is called as, in a unit time, is called as rate of reaction. Okay. Here the concentration is like the distance in the physics. Okay. I'm just comparing. It's not for real. I'm just comparing that. The distance here, the concentration here is acting as the distance there, and the time remains the same. Okay, the speed is equals to distance by time. Speed is equals to distance by time. Similarly, here rate is equals to concentration by time. That's it. This is the only proper definition where you will be getting. So, since the concentration acts as the distance, the time remains same. So, the rate of reaction is nothing but the decrease in the concentration of reactants or increase in the formation of products in unit time, in 1 second, is called as rate of reaction. let's see this formula. Rate is nothing but for reactants. What is happening? Suppose, okay, before going to the formula, I'll be explaining you by taking one example. Okay, now A plus B, suppose there are two reactants, that is A and B, and therefore A plus B gives products. Okay, A plus B gives products. Here A and B are the reactants and products, whatever may be the product, let us leave this for this at this instant. Okay, A plus B gives products. What happens? Okay, for your better understanding, more organized way, let us consider this. The two chemicals A and B, reactants A and B, combine to form C. A and B are the two reactants which combine to form C. Here, how the rate is defined? Suppose we consider one of the reactant A. From A, how it is forming C? Just simply. Now, okay, A and B, you take A and B also. The decrease in the concentration of reactants and increase in the concentration of products in unit time, that is 1 second, is called as the rate of reaction. Means that, see, whenever you have some reactants in the two beakers, if you have some two beakers A, if you have some two beakers A and B, the reactants are filled. Okay, when these two reactants are there, okay, when these two reactants are there, in the initial state, before combining them, the concentration of reactants is what? The reactants you have, initially what's the concentration of reactants? It's fully amount of reactants are there. No product is there. Zero product is there and 100% reactants are there. Okay, what happens if you combine the two beakers having the chemicals A and B reactants? If you combine, what will happen? In separate beaker you are taking, you are having 3 beakers. In 2 beakers you are taking A and B as reactants, and you are pouring those two A and B in some another beaker C, which will form product C. Okay, if A and B are poured into C, what happens? The concentration of reactants which are there, right? The reactants have initially 100%. Now after combining, the concentration of the reactant is being decreased, right? When you are combining, the concentration of reactants will decrease. Gradually the concentration of products has increased. Since you are forming the reactants and you are getting the products, means the reactants concentration is decreasing and product concentration is increasing. Okay, if you are not understanding now also, I will tell another very easy example. In this example only, say let us initially, okay, I hope you noted this, so I will rub this. Okay, instead of imagination, if I visualize this here, it will be very easy for you, right? You just note down if you have not written here. Okay, right? Be chill, don't be tensed. Okay, we will be understanding each and every point from scratch. This is my guarantee. Now, suppose the reactants A and B have 100 molecules each. Okay, 100 molecules. Okay, each 100 molecules of A and 100 molecules of B. If you have 100 molecules of A and 100 molecules of B, okay, and some C is being formed if you combine these two. Okay, suppose this reaction is taking some more time, about some 10 seconds. It is taking 10 seconds. Don't calculate, just understand. And don't see why you are doing like this, why 10 seconds, not 5 seconds. So just see the example, that's it. It's taking 10 seconds. And suppose you have initial 100 molecules of A and 100 molecules of B, C is to be formed, and it is taking some 10 seconds. So, okay, for easy understanding, let us take 5 seconds. Okay, see, initially when you combine A and B, it will take some time. So see, whenever chemical reaction you perform, it will take some time. It's not like you combine and immediately within fraction of seconds the product is formed. It will not happen for sure. The mechanism behind this is that this 100 molecules are there, right? 100 molecules of A and 100 molecules of B are there. Suppose in first second after combining, this A will be some 20 molecules will be combined. Some 20 molecules will be combined, and some for B also say some 20 molecules are combined. This A and B, 20 molecules of A and 20 molecules of B are combined in the first seconds. First second means how many molecules of each are remained unreacted is 80 molecules. 80 molecules are being unreacted. What is happening from 100 molecules of A and B? It is changing to 80 molecules of A and B. Means what is happening from 100 molecules? The reactants are decreasing to 80 molecules each. Means what is happening? From 100 to 80, what is happening? Decrease. The amount of decrease is happening. So the decrease in the concentration is happening. So the decrease in the concentration of reactants is called as rate of reaction. In a unit time is called as rate of reaction. I hope this is a very best, it is a too much best example, so no one can provide. Now in the first second, A is forming 20, A is combining 20 molecules and B is combining its 20 molecules. Thereby 80 molecules are being uncombined. Means what is happening in the first second? This C is forming 20 molecules. From 0 it is going to 20. Okay, in second to second. Okay, 20 molecules, right? If you are good at calculation, then don't worry. It's 20, 40 molecules of C are forming together. Since according to Dalton, amount of mass can neither be created nor be destroyed. Similarly, molecules. Right? In second, for example, some again 30 molecules of A and 30 molecules of B. In second, 30 molecules of A and 30 molecules of B again are combining. Means this 30 molecules of A and 30 molecules of B are combined in the second. Mean totally first and second, how many molecules of A and B are combined? 20 plus 30, 50 molecules are combined. 50 molecules are combined. Means totally in first and second, at time t is equals to 2 seconds, what is happening? 50 molecules of totally this 50 molecules of A and 50 molecules of B, means you are getting 100 molecules of C is forming. What is happening from 0? Just concentrate this. From 0 molecules of C, means 0 concentration of products, you are going to 40 molecules, means increasing again. From 40 it is going to 100 molecules, and from 100 it will increase and so on. At 5th second, some 500 molecules are formed. For example, don't calculate properly. So at 5th second, after completing the reaction, you have some 500 molecules of C formed. Means what is happening to A and B? At 5th second, A and B will become 0. That's the thing. At the last second, the concentration of reactants A and B becomes 0. What is happening from initially from 100 molecules of A? So, okay, you should be calculated, right? So it's 200 molecules. Where 200 molecules of C is forming. Means from 0 molecules, at 5th second it is ending up with completely 200 molecules are formed. Means what is happening in the products? It is increasing the concentration. From 0 it is going to 40, for 40 it is going to 100, and so on up to 200 molecules are formed. Means from 0 to 200 it is increasing. The amount of products, concentration of products is increasing. Therefore, the rate of reaction is defined as increase in the concentration of products. In a unit time is called as rate of reaction. Or if you want to define in terms of reactants, what is happening? It will decrease the concentration from 100 molecules of A and B. At 5th second, at the last second, it is becoming 0. Means the decreasing amount of concentration is decreasing. The decrease in the concentration of products, the decrease in the concentration of reactants in unit time is called as rate of reaction. This is the thing I wanted to explain. I think it took more time, but understanding is very much important, since the whole chapter is centered around the rate of reaction. Don't worry, even if it is late, we should understand properly. Time is not the factor. We should understand in a proper way. Whatever we learn, we should learn it perfectly. That's it. I'll also write the formula for this so that it's very easy for you to understand. Now let us see the formula. Suppose you have a reaction like reactants gives products, that is R represents reactants and P represents products. So let us have a reaction where R gives P, that is reactants gives products. According to this, we'll write the formula of rate of reaction. So rate is represented by small r. So rate of a reaction is equals to what is the definition? Rate of reaction is the decrease in the concentration of reactants and increase in the concentration of products is called as rate of reaction. Rate of reaction is what? Decrease in the concentration of reactants in unit time and increase in the concentration of products in unit time is called as rate of reaction. So rate is equals to, we are defining for reactants first. First for reactants we'll write the formula and after that we'll write the formula for the products. What is happening? Decrease. See, always in any everywhere, increase means positive, decrease means negative. That is the only thing. So increasing, suppose anything is increasing, increase means positive, decrease, this is by convention. There's a convention that increase means positive, decrease means negative. This is the thing. Okay, increase means positive, decrease means negative. So since the reactants are decreasing in the concentration, you should represent with negative minus symbol. So rate of reaction is equals to rate of reaction R is equals to minus concentration of the reactant. See, concentration is represented by like this between the square brackets. So rate of reaction is equals to minus concentration of reactants by time. Rate of reaction is decrease in the concentration of reactants per unit time. So unit time is T. Okay, this is the formula for rate of reaction in terms of concentration, in terms of reactants, in terms of concentration of reactant. Now we'll write the rate of reaction in terms of products. That is, rate of reaction is defined as the concentration of products, the formation of products per unit time. That is, rate of reaction is equals to, since increase is positive and decrease is negative, decrease is negative, so for reactant we are keeping negative, for rate of reaction is equals to concentration of products per unit time. This is the formula for the products, that is in terms of CONC means concentration, don't confuse. CONC, this is whatever I writing means concentration of products. Okay, rate of reaction is defined as the decrease in the concentration of reactants per unit time or increase in the concentration of products. So rate of reaction is equals to concentration of products per unit time. Just note this down. One more thing is that you should observe one thing. This is normally we can represent like this, but what does it really mean? We are defining the change in concentration. The change is always represented by a letter called as delta. Delta means change. We are getting one change, so that rate is, we are defining rate. So before the concentration, change in concentration rate, change means delta by change in concentration of delta. For if you are applying delta to a reactant, to numerator, you should also apply for denominator. So reactions are equal change in concentration of products by delta T. This is the thing. Like this you should define. Whatever you are representing this rate, this is normally when you are defining rate, you can use this. But actually, in this chemical kinetics, this delta concentration of R by delta T and delta concentration of P by delta D represents the average rate. You should have, if you have good knowledge in physics, then basic knowledge in physics, you can easily ace this. Okay, right? One thing, see, if you want one easy example, I can give you here. I hope it's visible to you. Suppose if you take velocity, suppose if you take the velocity represented by v, velocity v is equals to average velocity. If you are defining the velocity, average velocity v is equals to delta x by delta t. You will represent like this, and instantaneous velocity v is equals to dx by dt. If you remember properly, in the motion in a straight line chapter, velocity v is equals to delta x by delta t. Velocity v is equals to dx by dt. Velocity v is equals to delta x by delta t is the average velocity, and instantaneous velocity is v is equals to dx by dt. Well, delta x by delta t is nothing but the average velocity. Dx by dt is nothing but instantaneous velocity. Wherever the word instantaneous is used, the derivative terms will come into play. Where you should use, instead of delta, you should use the term d. That is the derivative. For derivative, you should consider instantaneous point. Okay. Whenever the word instantaneous used, you should use delta, not delta d. For average, you should use delta symbol like this. If you understand velocity v, average velocity as v is equals to delta x by delta d, and instantaneous velocity v is equals to dx by dt, you can easily link with that topic. Similarly, rate, you will be also having the average rate and instantaneous rate. You just note this down. I will tell you about that. It will give you some 5 seconds. You just take a screenshot or write down by pausing the video. Now I have written, you just compare this velocity v, or you can take acceleration also. So velocity v if you take, okay, you will be having two types of velocities, that is average velocity and instantaneous velocity. Okay, let us consider the velocity v. We have two types. I already told you, but I again telling you so that it's easy for you here to understand. So velocity v, average velocity v is equals to delta x by delta t. Average velocity v is equals to delta x by delta t, and instantaneous velocity is v is equals to dx by dt. Average velocity is v is equals to delta x by delta t. Instantaneous velocity is v is equals to dx by dt. So comparing this velocity with the rate, you will be similarly, by seeing, if you don't remember, if you are not getting and you are not remembering the thing of average rate, you just remember this, you just recall this average velocity. If you are not getting the instantaneous rate formula, then you take the formula of instantaneous velocity and get the answer. That's it. Okay, now we are comparing this average velocity with this average rate. So average rate is equals to dx delta x by, average velocity is equals to delta x by delta t. So average rate is equals to delta concentration of c by delta t. Since here the distance, I already told you, distance is like concentration. So delta x by delta t, here in this rate you should replace with concentration of c. You should replace x with concentration of c. So average rate is equals to delta concentration of c by delta t. Average rate is equals to delta concentration of c by delta t, similar to delta x by delta t. Okay, I hope you got this. Average rate is equals to delta concentration of c by delta t, and the instantaneous rate, and this instantaneous rate is similar to instantaneous velocity, that is dx by dt. Instantaneous rate is equals to d concentration of c by dt. So instantaneous rate is equals to d concentration of c by dt. If this c is nothing but I am representing commonly for both reactants and products. For commonly reactants and products I am representing with c. Okay, if the c is r, means if the c represents reactants, then you should consider, since it is decrease in concentration of reactants, right? So if c is r, you should take c is equals to minus r, and if c is p, that is product, then it's plus for p, as you know. So d concentration of c by dt. That's a simple thing. So I am just defining and telling you very slowly at this topic, because if you won't understand this, the whole chapter will be a nightmare. So if you understand this, you can easily grasp the concepts. If I ask you to write the example, if I am giving you an example, if I tell you to write the rate of this equation, this reaction, I am giving you the reaction, that is A plus B gives C plus D. In this reaction, you should write the rate in terms of every reactant and every product. What you will know? Yeah, I am giving you a question. Example is A plus B. I am giving you a reaction, that is A plus B gives C plus D, where A and B are the reactants and C and D are the products. A plus B gives C plus D, where A, B are the reactant and C, D are products. In this reaction, you should write the rate in terms of each and every reactant and each and every product. Means in terms of A, B, C, D, you should express the rate. So express rate in terms of reactants and products. So rate of reaction, you can represent it smaller, right? Rate R is equals to, in terms of ABL, right? So rate of reaction is equals to decrease in the concentration. See, you remember one thing. In the real world or the problems which you solve, you should represent the rate as instantaneous rate, not the average rate. Okay, the delta C, concentration of C by delta T is for understanding, and in very few questions you will be seeing it's almost negligible. So in everywhere you will be considering the rate as instantaneous rate only by default. So instead of mentioning in terms of delta, since the rate R is being expressed in instantaneous everywhere, so we will also go with the flow. Okay, we will also represent as instantaneous rate. So rate R is equals to decrease in the concentration of products. Rate is nothing but decrease in the concentration of reactants. Decrease in the concentration of reactants. So minus D concentration of A by dt. You can also express in terms of B. See, rate of A, rate in terms of A, rate in terms of B, rate in terms of C and D will be same. The answer won't change. And this is also equals to rate in terms of B. That is, since B is also reactant, minus D concentration of B by dt. Rate is nothing but the decrease in the concentration of products per unit time. So is equals to minus D concentration of B by dt. If you represent in terms of the product C, then since it's product, for we represent plus, so plus D concentration of C by dt, which is also equals to plus D concentration of D by dt. By this, what you can understand, you can conclude one thing. that if you are given only the concentration of C as, suppose you are given the concentration of C as 0.1 molar, can you find this? It's very easy. You can easily find. Okay, you can easily find by applying the formula. Not this derivative. You have some special methods for finding the rate of reaction. This is just for representation purposes. Okay, if you are given, for example, if you are having the 4 components, you have 4 molecules in the given reaction, that is A, B, C, D. A, B, C, D you are having, in that you can find the rate of reaction by using any one of the component. Okay, either by using A, B, C or D, anything you can find. Suppose if you are given with C, you can use this type of equation and solve the equation. That's it. Just note this down. We'll go to the okay, I'll continue this. See, average rate I told you, right? How the average rate means the average rate R is equal, in board exams you will be definitely getting this this definitions, and you need to give the formula. Average rate is equals to, since it will be defined as delta concentration of C by delta T delta is nothing but change, that is final minus initial. Delta is nothing but final minus initial. Final minus initial, you should write that, let's write like this. Final, let us say CF represents CF minus CI by TF minus TI. I think you have learned this in physics, but again I am telling you, delta concentration of C by delta T means concentration of finally minus concentration of initially by T final time by initial time. This is the thing where you will to get the average rate. Okay, just note this one. I am telling you point to point so that you will have no doubt. See, if you even try to study before listening, understanding, it will take more time. If you even study for one whole day, you will not be able to understand. So once you listen the video, my video, you can, I think, instead of one day, you can cover in 1 hour also, because if you understand properly, you can easily grasp the concept. Here I have plotted the graphs between the reactant concentration and the time. Here I have plotted the graphs. Here we have plotted the two graphs. Okay. Let's consider this part. We have plotted the two graphs related to the. We are plotting the two graphs between the concentration of reactant and the time. We are plotting the graph of concentration of reactants versus time. If you consider this graph, reactant concentration in molar and time is in seconds. If you take this average rate formula is equals to that is delta concentration of C by delta T. Okay, delta means final minus initial. So if you plot a graph between reactant concentration and time, see, as I already told you, the reactant concentration will decrease with time. Since the rate of reaction is nothing but decrease in concentration of reactants, rate of reaction is nothing but decrease in the concentration of reactants or increase in the concentration of products is nothing but rate. So here by default the rate of reaction is decrease in concentration of reactants. Therefore means decrease in concentration of reactants in unit time, means in a given time the reactant concentration decreases. Therefore if you plot a graph between reactant concentration versus time, you will be seeing decrease in the concentration which is exponentially decreases. It exponentially decreases the concentration. If you want to plot average rate, average is nothing but final minus initial. Therefore you are considering some 2 points of time concentration and 2 points of time, where the concentration at this point is C2 and concentration at this point is C1, and at this point the time is T1. Initially when the concentration is T1, that is its corresponding time, and C2 concentration at that time the time is T2, corresponding time. C1 concentration at time T1 and C2 concentration at time T2. The formula is this. It is how it is derived. This is how it is derived and represented. In exam also, if you write this along with the definition, you will get full marks. Nobody will see your definition directly. They will give the full marks, no doubt. So for instantaneous rate, if you write this, so rate is equals to, here the rate is equals to d concentration of C by dt. Okay, d concentration of C by dt. So the reaction rate, if you see the plot versus, if you please see the plot of reactant concentration, if you see the plot of reaction concentration versus time, it will be exponentially decreasing similarly, but for getting the instantaneous rate, you should always consider one single point at infinitesimally small point. At an infinitesimally small point, very small point, you should consider the time as dt and the concentration as dc, where d concentration of C dc, then rate is equals to d concentration of C by dt. That's it. So this is the graph you need to understand. Okay, after that we'll proceed to the other part. This is a very important note point, and this is a direct question which I have seen in the previous JEE and NEET questions. In previous JEE and NEET questions, I have observed this type of model where the coefficients for the reactants, where the not normal coefficient. If you have normal coefficient 1, 2, 3, then you can directly write. But the thing is that if the each of the reactant and product have different coefficients, then this is an important model which you will be seeing in the competitive exams. That is, this is a note point. You should write it very clearly in a book where it won't be lost. Okay, you should keep it this very safe. Note, if you have a reaction of the model, don't confuse. If you have normal reaction, A plus B gives C plus D. A plus B gives C plus D. I have shown the reaction previously. For each of the reactants, so for reactant A, you have number of moles as A. For B, reactant capital B, you have the number of moles as B. For C, you have the moles as C. For reactant D, product D, you have the number of moles as D. That is, AA plus BB gives CC plus DD. A small alphabets, lowercase represent here the number of moles, uppercase represents the corresponding reactants or products. So for this we have written the rate. I will also give you the general conclusion. This is a model how you will get in the exams and how you should solve. The rate R is equals to, see, if the coefficient whatever it is there here, you should reciprocal it and write. That is, if you have A, you should write it as 1 by A. That is, in the given moles, you should reciprocate it. You should write it as its reciprocal. So rate R is equals to, since normally without this 1 by A, you see rate of reaction is nothing but decrease in the concentration of product. So rate R is equals to minus D concentration of A by dt. Rate is equals to minus D concentration of A by dt. But one thing is that if you have this number of moles here, you should multiply with this reciprocal of the A, that is number of moles. Normally you'll write the rate as minus D concentration of A by dt, but you should multiply, since there is a coefficient, there is number of moles, you should multiply with the reciprocal of the moles also. So the one thing is that if you have number of moles, you should multiply with the reciprocal. So rate is equals to minus 1 by A D concentration of A by dt, 1 by A. Similarly, for B also, normally if you don't have B, this small coefficient, there is minus D concentration of B by dt. So multiply with the 1 by B. Here, with in terms of C, rate is equals to D concentration of C by dt. Okay, since you have this coefficient, 1 by C, similarly 1 by D. The thing is that the general expression we will be writing is rate of a reaction R in this type of models. Rate R is equals to D concentration of C by dt multiplied with the coefficient, let us say X. This is the general form. Rate R is equals to 1 by X into D concentration of C by dt. Okay, here X is nothing but the coefficient, that is stoichiometric. This is nothing but the stoichiometric coefficient. This X is nothing but the, here the X is nothing but the stoichiometric coefficient. X is nothing but the stoichiometric coefficient. Stoichiometric coefficient is the coefficient which is present before the corresponding reactant or product. X is the stoichiometric coefficient. So this is the thing. This is general thing. The C can be either reactant or product. C can be R or P. If it is R, it should be have minus. If it is P, that is product, it should be plus. You know it very well. Just take a screenshot. This is only the first part of the video. You'll be seeing the second part and in next time. Okay. After this after completion of this video, you can see the other part. This is a basic thing you need to understand. Based on this rate, how the rate is expressed in terms of reactant, how the rate is expressed in terms of product, and how the rate can be expressed instantaneously, how rate is expressed in terms of average rate, and how in terms of if there is a stoichiometric coefficient. These are the key points. These 5 key points you need to understand. After understanding this, you can understand the further concepts such as rate law. The rate law is also there, where you will be having zero law, first order of reaction, for first order reaction, zero order reaction, second order reaction, for nth order reaction. For these type of reactions, you will be having the rate equation only. There also you should understand how the coefficient, how the rate should be expressed if the coefficient is there, and in terms of reactants, products. This type of manipulation you should be doing in the calculations. Thank you. Keep watching.